Okay, we're going to look at magnesium and oxygen. We will look at those two for our second example in lesson 19 of our Living by Chemistry book. Magnesium is in the third period, so it's going to have 3 shells. And it is atomic number 12, so this atom here is going to have 12 protons and 12 electrons. We always start with a neutral atom here. The first shell has a maximum of 2 electrons. The second shell, oops, there we go. The first shell has a maximum of 2 electrons. The second shell will have up to 8. That takes me up to 10. Magnesium is in group 2A, so I need 2 valence electrons, which happens to take me to 12. That's pretty handy. So 2 valence electrons. Oxygen is in group, no, it's in period 2, so it has 2 shells. Oxygen is atomic number 8, so it has 8 protons and 8 electrons to start. First shell has 2 electrons and then it's maxed out. That means I need 6 more in the second shell. And that also coincides with 6 valence electrons, with oxygen being in group 6A. All right, so oxygen and magnesium were hanging out one day and they both said, we can make this better. Magnesium said, I would just as soon ditch 2 electrons and I will give them to oxygen. So magnesium loses 2 electrons. Notice it loses all of its valence electrons. It had 2 valence electrons and it loses 2 electrons. Once magnesium has done that, now we're from 12 protons, and now we only have 10 electrons because you start with 12 electrons, you take away 2, now you got 10. This right here gives us the overall charge on magnesium. That's 2 plus, 2 positive, because we've got 2 more positives than negatives. So let me write down Mg2 plus. And it doesn't matter if you go 2 plus or plus 2. The charge is positive and its magnitude is 2 because we lost 2 electrons. Notice, well, okay, first I'll go over to oxygen. Oxygen is going to gain 2 electrons. It's convenient to note that oxygen had 6 valence electrons, and now it has gained 2 more to give it 8. It's filled up that shell. Oxygen started with our 8 protons, but now we have 10 electrons because we gained 2. So the charge on the oxygen ion is given by combining these 2 numbers, and that's going to be O2 negative because we've got 2 extra negatives. It is a challenge to remember that you're gaining electrons, therefore you become negative. So up here, that right there is not a mathematical operation. It's telling us we've got 2 extra negative charges. And here, we've got 2 extra positives, or alternatively, you could say we lost 2 negatives. Interesting thing to note here is once oxygen, I don't know what color to use. Once oxygen does this, it has the same electron arrangement as something with 10 electrons, that would be neon. So it has the same electron arrangement as neon. Neon is a noble gas. Neon is known to be very stable. That electron arrangement is very stable. Look what happens to magnesium up here. Magnesium loses these two valence electrons, which means that shell is now gone. It's empty. Look what's left behind, and that is the same electron arrangement as neon. Right there. A noble gas. So the bottom line is, when an atom has a small number of valence electrons, it tends to lose those. When an atom has a large number of valence electrons, it tends to gain electrons. And that would take us to here. That's the wrong picture. Let me go to this one. The atoms with small number of valence electrons are in groups 1, 2, we don't care about those, 3, those are metals. Metals tend to lose electrons. Atoms with large numbers of valence electrons, 7, 6, 5, those are nonmetals. Nonmetals tend to gain electrons. And this one right here in the middle is just going to kind of be special. And so it's going to do what's easiest. So right here, is it easier to lose 2 electrons or to gain 6? It's easier to lose 2. And we will cover the rest of that tomorrow.